Yeah, you are on live on YouTube, right?
Okay. How's it going, everybody? I'm Steve. This is Paul.
Hey, guys.
And we're going to talk a little bit about SpringIO today and a little bit about Mongo DB. So with that, let's jam.
All right. So the title for our presentation was Bootiful Mongo. Bootiful came from Spring started Spring Boot. So every tagline they have now is something beautiful. So I'm just ripping that right off. I'll start things with transitioning to Steve's Mongo presentation.
How's it going, everybody? I'm Steve. This is Paul.
Hey, guys. That's a delay.
We're going to talk a little bit about SpringIO today and a little bit about Mongo DB.
So how do you get Bootiful? You have to start somewhere. Spring has a new start platform that I'll be demoing live. IO. It's not you. You need to use IO. If you don't like dependency help, keep doing like the individual char management. Otherwise, start using IO. Boot. I'll whip up a quick boot app. You'll see that the code is tweetable, so it's pretty cool. And then lastly, I'll show a little bit of data, simply because that's our transition point. So I'll get us going here. So start.spring.io. Has anybody used this website? I hadn't heard about this until I went to a Spring conference, but it's really kind of cool. If you start a Spring project today, what do? You typically find another like Gradle or Maven file that does what you want, or something similar to what you want to make some mods. Well, start.spring.io kind of gives you everything you need. So you can select which Spring projects you want. So in this case, I'm going to say web. I'm going to say REST repositories, Mongo DB, because that's our flavor of the day today. And lastly, I'm going to bring in the actuator, which is kind of Spring Boot's management tool. So I'm going to fill in a couple of the other details here. So we're going to be over TechJammer. We're going to do a demo. Sure, we can call it demo. Gradle project, and I'm going to use Java 1.8. So this just zipped me up a quick little demo project that's going to be everything I need to get rolling with Spring Boot, and start my actual demo. Don't worry, IntelliJ fans and NetBean fans, your ID has nothing to do with this. Which is most of my team here. So I'm going to import my Gradle projects. So like I said, we get a few things out of the box. Since I selected a Gradle project, I got a build Gradle file. It has the dependencies that I asked for using SpringIO. You'll see Spring Boot is called out. So already I've got a project that I can build. I can run tests. And lastly, I can run Spring Boot and actually run my app. So let's get to that app portion. Has anybody used Spring Boot? How many people here like heavyweight application servers? Nobody, right? Nobody likes working in the WebSphere world. Nobody prefers that sort of environment. So you want something fast, really lightweight, so you can be really efficient doing development and not hold you back as you're trying to get things done. So I promised you a tweetable application that can actually run an app via web server. This is it.
Bump up the font.
Oh, my apologies. Everybody can see that? That's my tweetable application. You'll see that I've got a good old public static main, All the magic really lies in the annotation of a Spring Boot application. So what this does is it kind of replaces, or adds on top of, I should say, the base like component scanning that Spring can give you. A lot of places, you know, if you have an application that's a few years old, it's probably using XML to configure your beans. Otherwise, you're using the Java config. You know, either way is great. This just cleans it all up. So I'm just gonna run this guy as a Java application and show you what we get. So that's my app server starting up. It started in 3.7 seconds. What did I get? I got embedded Tomcat running my Spring config, which my Spring config is obviously pretty light, but it's embedded Tomcat, and it provided me a bunch of REST endpoints that you can use to help monitor your application because I added the actuator project. So now if I go back to a browser, I can start learning a little bit about my app. So I go to the root URL, I can get to Elps, which kind of can bring you into describing what services are available. But the pieces with the actuator that you get are things like env, so you can see all your environment variables. Kind of handy. You can look at the mapping side, so any of your contexts, what context you actually have in your app, you can see all that straight through here. All of your Spring beans, they have a way to do that. So as you can see, there's a lot here. There's health. You can create your own health indicators. You can. I'll show one more. You can get metrics too. So there are metrics, built-in metrics plugins, but you can also add your own things that you want to keep track of. So here you can see memory usage, your heap, number of classes loaded, etc. So all that out of the box is pretty sweet, right? I really haven't done anything, but I've got an app server up and running. My demo would look pretty sweet if I just stopped there, so I would just mail it in, but I'll complicate things a little bit. So I'm just going to add a REST endpoint. Method. Sorry. Steve. And just for fun here, I'll just make this the REST controller. Now Spring Boot, like I said, it starts up super fast. You saw it start super fast, so I can make that change, be up and running pretty quickly. Spring also has something called Spring Loaded. If you're familiar with JRebel, it's kind of their version of hot deployments. So you could be making live changes with your beans and see them near instantly on the screen, but so you can see here's my REST endpoint that I just threw up. Now, we have to start transitioning over to the data side. I mentioned this, and I kind of skipped over it as I started my demo, but this is what the ILO platform is. The ILO platform is like a bomb of all the Spring projects. It's everything that Spring says should be compatible. So even different Spring projects can be different versions, right? And it's sometimes hard to say, you know, Spring Data 1.2.3 is compatible with Core 4.2.1 or, you know, whatever that is. And then they have transitive dependencies that you have to worry about. If you use the IO platform and their jars, you get all that stuff for free, so you don't have to sit and figure it all out. It's one of the benefits of containers, right? A container will tell you what you can run, what they support. This is Spring's way of doing it. As I showed you, boom, easily create runnable Spring projects. The default container you get is embedded Tomcat. You can use Jetty, and recently they added Undertow, which is JBoss's embedded container. I haven't played with any other one than Tomcat, but it seems to work great. Like you saw, there's no code generation. You don't have any XML to configure. If you have that annotation in the Spring Boot jars on your class path, you're good to go. And lastly, like I pointed out, the actuator. It's the management monitoring tools. I'm trying to include links in here, so if you want to check stuff out later, just hit these links on Spring and see what you can learn. Now, lastly, I wanted to talk about Spring data. If you use a relational database, odds are you're using some sort of an ORM like JPA. Maybe you just do straight up Hibernate, or maybe nothing at all. Spring data kind of helps you with your data access. Why not get CRUD for free? There's really nothing that specific about what you're trying to do in Hibernate, where you need named queries that match up your variables and your objects to what's in your named query. So they came up with a way, an abstraction layer, so that you can do this for relational and non-relational databases alike. So I'm going to give you a quick little demo of that. I'm going to use Mongo because that's where we're going tonight, but certainly you can follow these principles with everything else, or with any other platform. So I'm going to create an entity class here. I'm going to call it TechJammers, or TechJammer. I'm anti-plural in my entity names. So all I got to do is give it an ID, so it knows what the ID field is. So I'm going to give it a couple of properties. So a TechJammer, you get an ID, a name, and a favorite sport. Now I need a Spring repository. The repository allows you access to access whatever data store you want to use. In this case, I'm just going to call it the TechJammer repository. And in this case, I'm using the Mongo specific one, so I'll extend the Mongo repository. I gave the ID as a string, so that's all I need. And to help facilitate the presentation, I will REST enable it. All right, so my container's up. I'm going to use a REST client. In this case, advanced REST client, or advanced REST client Chrome plugin. Yeah. So I just did a get on the collection. So what this is going to do is return me a default list of whatever TechJammers are in the collection. You'll also note that I never created a database collection in Mongo. I haven't done anything. Mongo will create that on the fly. I believe if you use JPA and for instance, say Hibernate, it'll do that as well. But here's what I get as a response. Oh, I even had data in here from before, so this works out great. So I've got 3 people in here. I've got Steve, I've got Paul, I've got Prafula. Steve and I, Steve likes ice hockey, I like football, Prof likes cricket. By default, the page size is 20, so you kind of get paging, which is really nice. Out of the box, you'll see 3 total elements, and I've only got 1 page of data. Now, because of the paging support, I can say get me a page with the number of elements of 1, so that's my size of 1. You'll see all of a sudden now I've got 3 total pages, and I can kind of page through the results. What I can also do is I can add, or I can do post commands, so I can immediately start manipulating my collection. So I'm going to add Prasad. Prasad's favorite sports must be cricket as well, wherever your bat is around here. Gotta love the live demos. Oh. I want to be able to post, so I need to flip that flag around. So I'm going to post Prasad. Steve, any button? That seems right. Well, what I will just do is what's going on here?
You're missing the record.
Yeah, it's just missing the repo.
What did you take out?
Should I just skip it?
What time?
Should be it.
Yeah, I don't know. You know what? Yeah, you lost your entire man.
Yeah.
When you added that last annotation,
I just removed the spring controller.
maybe try to put that.
Huh? Or the rest controller. Well, I removed it off the app, though. It's fine. Wow. This is how a demo goes, screeching to a halt. All right. So what I'm going to do is I'm going to leave the demo piece alone there. Steve, why don't you take off from here?
All right.
This does work.
Yeah. All right, so I'm going to talk to you guys a little bit about Mongo DB. How many here have played around with it? Anybody? A couple of folks? Okay, so most folks, it's relatively new to you. All right, so we'll start at the beginning, and then we'll gradually get into some of the more complicated aspects of Mongo, basically standing up a cluster, sharding, how replication sets work. So it's going to be a really, really quick intro. So I think you guys have done a couple of sessions on NoSQL databases, is that correct? Or at least one on the various flavors of NoSQL databases. So Mongo is a NoSQL database. Obviously, that's a huge swath of stores. This one is a document store. There's a lot of others out there that are document stores, and it's using JSON and VSON. So anybody that's familiar with JavaScript, has been working with JSON for a while, should come very familiar or look very familiar. VSON is just basically a binary flavor to JSON, which optimizes the storage aspects. So Mongo, just like in a RDBMS, has the concept of databases, and then collections in Mongo are analogous to a table. So, you know, if you're thinking in terms of SQL, collection relates to a table. Chunks is equivalent to a page. So it's a subset, it's a storage mechanism that's a subset of a table. Just like a page is a subset of a table, a chunk is a subset of a collection. And then there's all kinds of things that happen around chunks, just like in traditional relational databases, there's all kinds of things that happen around pages. So things like maybe partitioning, things like optimization around indexes, etc. And then you're going to see types that are very similar to types that you're used to working with in the JavaScript world. All right, so we're going to switch over here to a tool called Mongo View that kind of gives us a view into the world of Mongo and what things look like. There's a lot of things out there. This is a free version, so I'm going to connect to my local host, and hopefully we'll see some of that data that Paul was just showing you guys through those REST endpoints. So by default, there's a test database that was added through the process that Paul was looking at, and I can come out here and look at the TechJammer store. So there you guys can see Steve ice hockey, Paul football. Looks like Prasad maybe got added quite a few times, so that's the technical difficulty that Paul was going through. But you know, just like you've got rows in a database, you've essentially got the equivalent of rows in a collection. And so there's a number of different views that you can look at here. There's a table view, so you know, as you're new to Mongo, you know, maybe that makes more sense to you. Look at it from a row perspective. And equivalently, you know, it shows you the key value pairs as columns in the rows. And then behind the scenes, you know, if you're familiar with JSON, this will look very familiar to you, where you know you've got key value pairs for everything essentially. So Mongo's going to naturally add a string ID. It's an object ID, which is like a GUID. So that was that add ID tag. Behind the scenes, Spring Data is handling that for us. The class, that's how it knows, you know, how to hydrate the object. So again, JPA world, if you think about behind the scenes, there's SQL going on that's hydrating stuff into your classes. Same kind of thing going on with Mongo and Spring Data for Mongo. It knows now that demo.techjammer class, and it's going to look at key value pairs, you know, standard Java bean type stuff. So it knows that there's, you know, getter setters for name, getter setters for your favorite sport, and deals with that hydration. Does that all make sense? Anybody have questions? All right, so that's the Mongo intro. All right, so who's seen this YouTube video? Anybody know this guy? So it's pretty interesting. It's in the links at the end. It's a conversation between a guy who's a fanboy of Mongo and keeps talking about Mongo being web scale, but he doesn't have a clue why it's web scale. He's arguing with the MySQL guy. It's pretty interesting. It's kind of funny. And he keeps saying over and over again, Mongo is web scale. Well, it turns out he's actually right, but he's still an idiot. He really doesn't understand what's going on. Very funny, 5 minutes YouTube video. Check it out, and you'll have some fun. So this is where he doesn't understand a lot of the things that we're going to go through next. How many of you have heard of Brewer's cap theorem? So this is something that's been popularized by the guy from Amazon, AWS, Werner Vogels. You'll hear him talk about that. And he's popularized this where, you know, you can have two things out of consistency, availability, and partition tolerance. So going back to SQL databases and trying to scale SQL databases, it's really hard to scale something that's ACID compliant, right? So everybody knows what ACID is and what it guarantees for us. Well, the hard part of that is scaling, particularly the consistency piece. As soon as you start to have a cluster and you've got to guarantee that consistency of the data across the cluster, think of things like XA, so distributed transactions. What happens there, right? So they wind up taking too long, they wind up causing too many locks, and then you've got a whole bunch of stuff that piles up behind those locks, and it's difficult to start to scale that database when you get to very large volumes of data. There's a whole bunch of ways that people deal with that, but part of the NoSQL movement is eventual consistency. So instead of dealing with guaranteed consistency, you go for eventual consistency, which means the data gets written and you might have some data in your cluster that's not actually up to date, right? So think of it back to like isolation in the SQL world, right? So what do you do with your serialization piece? You will offer stuff like dirty reads, for example, with isolation levels in SQL databases. Well, the concept's very similar in NoSQL databases with eventual consistency. So again, with the CAP theorem, you can basically pick two. What do you want? Do you want availability? Do you want consistency? Do you want partition tolerance? It's very difficult to get all three. Obviously, that's the holy grail, but that's extremely difficult to do when a lot of these database vendors now, both SQL and NoSQL, are trying to figure out ways to get as close as possible to solving some of these problems. So if you look at this, you can see the blue are relational databases, so the typical SQL stores that we're used to dealing with. There's key value stores. Again, I'm assuming that a lot of you guys were at some of the previous tech jams where I talked about all these flavors of NoSQL databases. And there's really three, right? So there's the key value flavor, and you'll see various databases there in green that maybe you've heard of before. And you've got the column-oriented stores, so those are in red. Things like Bigtable from Google, they made that famous. And then you've got the document-oriented stores, and Mongo is one of those, right? And you can see where they fall in terms of CP versus CA versus AP. So that whole pick two is kind of a sort of, and we'll get into more of that and what it looks like as we move throughout the presentation. So how many of you guys have worked on systems where they've been really difficult to scale, or you've had some kind of problems with, hey, we didn't account for backups, or things like HA and we've got a node that fails and the whole system comes down? I think most people have dealt with that, right? It's on some level or another throughout their career. If you haven't, you're very lucky. Let's put it that way. So how do you scale systems, right? How do you deal with backups, things like disaster recovery? Sometimes they're not even thought about, right? So what's the thing people do a lot of times, and especially as with older systems where you didn't have to worry about scaling them from a data perspective, right? You get into it and pretty soon your manager's pissed off because you've got a problem, right? The customer is unhappy that the system's slow, or they're unhappy that the system's unavailable. More and more we need to be thinking about this ahead of time, right? We want systems that account for things like backups and disaster recovery and scalability. All right, so in the Mongo world, the way you solve some of those problems are through sharding and through what's called replication sets. So a shard is analogous, like if you guys have heard of shards in the Hibernate world, or a partition, they're analogous. So a shard or a partition are the same thing. It's how you carve up your data and disperse it across physical servers. And then the replication set is the piece where is dealing with the HA aspect. So if you've got your data replicated, right, and you lose this server should be able to pick it up, and you've got a copy of that data there, and it's transparent to the end user or to the client systems. So that's really how Mongo solves that problem. So we're going to go through and set up a cluster, and it's going to emulate 3 servers. I'm going to do it all on my laptop, but as you'll see, we're going to color code what we're doing and look at the server 1, 2, and 3. So the orange is going to represent our first server, blue is going to represent our second, and our green is going to represent our third server. And we're going to stand up a cluster. We're going to add some data to it. We're going to go through and shard it. We're going to set up some replication sets. And then we're going to kill one of our servers and see what happens to the entire system, right? So that's the HA piece of this. If we have a server fail in production, we obviously want the cluster to continue. And we want clients to not even see that. And again, going back to systems, I'm guessing a lot of you have worked on systems where if you have a server fail, it's an uh-oh, we're in trouble. And so we're going to try and emulate that as we go through this process. So in the Mongo world, there's the notion of config servers. They kind of know where everything's at in the system, and they handle all the configuration across the entire cluster. And then, as I mentioned, we're going to get into shards. And if you see here, a shard is, think of it as a hash map, essentially, right? It's distributing your data across how many ever shards you have based on whatever key you define. Just like with a hash map, you know, you put and get stuff based on keys, and it's actually hashing and spreading your data throughout the map. So we're going to set up a set of shards. So these are our shard ones, and we've got replications of those right across those 3 servers, again, for the HA piece of it. And then we're going to have our second shard. And just like with a hash map that we're traditionally used to dealing with, right, you can hash as big as you want, as wide as you want. In this case, we're just going to say there's 2 entries in that particular hash. But certainly, you know, as you build your systems out, you're going to have many more shards. So if you've got 50 servers, right, you'll have potentially 50 shards, or however you want to define it. But we're going to go with the bare minimum and set up 2 shards associated with that. So then in the Mongo world, there's the concept of what are called routers, and these routers are the things that know where the data lives. So which shard is my data on, which equates to which server is my data on, and then that's the piece that talks to the config servers. So we're going to go through and set all that up. And again, those routers are the things that know where my data lives. Is it on shard 1 or shard 2? Where's my primary server? Where do I actually need to get that data from? So it makes sense to everybody, at least conceptually. All right, so next what we're going to do is get into actually setting that up as we talked about. All right, so orange, remember, orange is our first server. So the first thing we're going to do is actually set up our config servers. That's the first thing you go do with Mongo. So I'm going to give it a -- config server. I'm going to tell it where my data's at. This is my actual laptop name, so I'm going to stand everything up on this laptop, and I'm just going to use different ports to represent those different servers. And before I do that, I think I got to wipe out my old cluster if I haven't done that yet. And that looks like maybe I have done. Okay, so we are starting from scratch. There's no data, there's no partitions. The other thing I've got to do, so the Mongo instance we were using before to serve up our data for that little sample app that Paul did, that was a standalone Mongo instance. I actually have to shut that down so I don't wind up with port conflicts in the cluster that I'm trying to build up. All right, so from a data standpoint, I've got this node 1, node 2, and node 3. Again, those are representing my 3 servers. And then I'm going to start up that first config server as I mentioned. Then I'll start it up on my second, again, physical server that's represented by the green. And then I'll start up a config server on my third virtual machine, so to speak. So if we look back here, right, this is where I'm at right now. I've stood up my 3 config servers. They're, again, the places, they're the things that store my configuration associated with my cluster. So now I'm going to come over and I'm going to configure what are called those routers. And those routers, again, are the things that know where everything lives. So again, Mongo S is the things that's used for configuring routers. I'm going to call it a config DB, and then I'm going to tell it that these are my 3 config servers. So those 3 config servers I just started on port 20, 21, and 22. And then my Mongo S instance, this router, is going to start on port 27017. So everything looks good, no issues there. I'm going to start up my second router, because same kind of thing, right? If one of my routers fails, I don't want to have a single point of failure in my system. So thus I'll start up multiple routers that can handle the routing of requests. So I've got both of those guys started up. The next thing I'm going to do is I'm going to set up my shard 1 on each one of those servers, and then I'm going to set those shards up as a replication set. And again, the reason for the replication set is when I write my data, it's going to write it to all 3 nodes, so that if I have a node fail, I don't lose any data associated with that particular node. All right, so here, these are Mongo DB instances, which are actually the data servers. I'm going to tell it where my data lives. So this is my node 1, which is emulating my server 1, and I'm saying that this is for partition 1, which is analogous again to a shard 1. And then where am I binding it to? I'm actually binding it to my local machine name. All right, so that guy's up. It's sitting there saying I have an empty config, and eventually I'll have to config that, and we'll go through that. But as I stand up each 3 of these guys that are going to represent my shards that are replication sets on each of my 3 servers. All right, so they're sitting there. They're going to complain for a while. They're saying that they haven't been set up yet as a replica set. So now I'm going to come over here. I'm going to connect to one of those 3. In this case, the orange one. So all the ones that are end in a 0 are my orange. All the one in green end in a 1. Everything in the blue ends in a 2. So now I'm connecting just through the Mongo shell. So this is just like, connection to a database where I want to execute my SQL commands. That's what's going on here. So I'm going to give it a command of rs.status. RS stands for replica set, and it's telling me that I haven't set up this replica set yet. The first thing I'm going to do is initiate it. So this is where it's going to configure and say, oh, I now know that these 3 servers and this partition are acting as a replica set to deal with that failover of data. And so right now I'm on that first node, the orange node. I'm giving it an rs initiate, and you'll see what it's doing now. Instead of complaining about no replica set being defined, it's actually going through and chunking out that data essentially. So on those partitions, it's reserving some space. So just like when you build a table, in most SQL databases, it's going to go out there, allocate a chunk of data for that table. Essentially it's that, again, back to those pages, it's doing the same thing with chunks in that world. All right. So now if I execute my rs.status, I've got that first node. So here it's telling me partition 1. It's saying, again, the ones that end in 0, that's my orange machine. I still haven't set up my green and my blue. So the next thing I'm going to do is go to my green machine. And I'm going to say, I want to add that replica set on that machine to this replica set. So now I've got a second one in there, and you'll see this guy, same thing. He's going through and filling up or carving out the initial data storage for that particular machine. I can now see my status. This startup 2 is basically telling me it's in the process of going through and adding that to the replica set. And eventually it should tell me it's finished. So now this is telling me, right, so this is my node that ends in port 0. It's my primary store, so that's where all my writes are going to occur. And then they're going to be replicated to my first secondary store. And now it gave me an OK1. I'm going to add it to the port that ends in 2. And correspondingly, I can again look at my status. I now see my third node in that replica set that's named by this partition 1, and it's in that startup phase. Make sense so far? I'm walking you guys through the hard part of this, so hopefully people understand conceptually what's going on. But with all of that said, there's much easier ways to do this, and I'll show you at the end what one of our stage servers looks like, where you just basically have a config file and start up your Mongo instance, and it does all this stuff behind the scenes. So obviously that's a much better way to do it when you get to production systems. But again, that's very difficult to explain conceptually what's going on. So bear with me on the conceptual aspects of this. All right, so over here, this is where we're at, right? We've got our first shard built, and it's replicated across those 3 machines. The next thing we want to do, look at my notes here real quick so I don't. All right, so we started our partition 1 servers. We initiated a replica set. The next thing I want to do is add a shard and enable it on a database. All right, so right now I'm connecting to one of my routers. There you can see my RS messages. Check here. So this is a blog post I put out there quite a while ago. The last time I did this demo, I wanted to remember how I did it, because obviously there's quite a bit going on here. All right, so I connected to one of my shard servers. Now I'm actually going to add that shard. I'm calling it partition 1 in this case. And then my machine name. All right, so it's telling me I had my shard properly. I'm now going to create my database. We're going to call that our test DB, and we're actually going to enable sharding on that database. So just like an admin on a SQL database has to go through, got an extra D there, go through this process. On a SQL, you know, we've got the analogous DBA role in a Mongo world. All right, so I asked it for my shard status. It's telling me my shard status. The key thing here is it's telling me I've got a shard called partition 1. Here you can see again all those machines that are in my cluster. There's the notion of an admin database, just like you have internal databases in a SQL world. In Mongo, you have the equivalent. And then here's my test DB. It's telling me it's partition, and I've got a primary partition called partition 1. All right, so the next part, I'm going to go through this fairly quickly. We're going to set up our partition 2. Conceptually, the same thing's going on here for my second partition. And just to reemphasize what a partition is doing, right? So machines typically only have a fixed amount of storage, right? And then you eventually run out of storage space, or you get such a large disk array that you wind up having trouble scaling it, right? So think in terms of like a SAN or an NFS system. What this is doing is allowing you to carve up that data across your nodes, right? So if you, let's say you've got a disk on your machine that can only support, let's say, up to 10 terabytes of data, right? So what do you do if you need more than 10 terabytes of data? Well, in the Mongo world, you create a partition, right? And so I've got a partition, and I'm going to store 10 terabytes over here and 10 terabytes over here, and now I've got a system that can support up to 20 terabytes, right? So that's the concept around that. And then the big thing there is the horizontal scalability, right? So now what do I do when I need a petabyte of data? Well, I built that many servers, each with 10 terabytes. That will give me the amount of storage that I need, and it's still a responsive system when it comes to reading and writing that data. So that's the whole reason why we go through this exercise. All right, so now I'm going to connect to my second partition that I just stood up. In this case, oops, that's the wrong guy. That's my partition 1. I want to connect to my partition 2. So right now, I just connected to this guy right here. I'm going to go through that same exercise, and I'm going to make him my primary. The reason why I'm doing that is I want to show you guys the failover capabilities where I'm going to fail one of the primaries, and we still have a cluster that works the way we expect it to. So here again, you can see he's allocating the data from my cluster. And I'm going to do my status. And then I'm going to add my 10 node, which is my orange node. You can see him start to spin up. And I'm going to add my 12 node, which is my blue, and you'll see that start to spin up. All right, so you can see both of those guys are in a startup mode. So once I've done that, I need to add my second shard to my machine. So I'm going to switch back over here. All right, so now I've still got my partition 1. I've actually got to add my second partition. Right, and that's on my 11 node, I believe. All right, so now you'll see previously I just had that single partition. Once I added the second one, I now see both of these guys added. And I can see essentially my 6 Mongo instances, right? So 0, 1, and 2, 10, 11, and 12. I've got my replica sets and my shards set up. Makes sense? Anybody questions? All right. So the last thing we want to do, right, is make sure we're getting close here. We're going to start adding some records to our database. All right. So the way we're going to do that is I'm going to say use my test DB, and then I'm going to go through and add some really simple records in that database. And eventually, what we need to do is push that over that chunk size I was mentioning, because those chunks are how it deals with the partitioning of the data. So I'm going to add 100,000 records that just contain this editors. Right, so it's going through now and it's adding 100,000 records to my database. If I switch back over here to my Mongo view, I'm gonna remember this was my non-cluster. I'm gonna reconnect. I stood it up on the same port, so I shouldn't have to change anything there. That test DB that we've been talking about. There's my collection, and I can start to see my data in there. So again, we've got an ID in there. Since I'm not actually I don't have Spring data sitting on top of this yet. It doesn't have that class name that we were talking about before, but I could see my elements being added to the system. If I switch back over here, it should be done now, so I can say db.mycollection.count, and I can see I've got 100,000 records in there. So next, we've actually got to shard our collection. So you can shard your collections in different manners in the system. And so what we're going to do here is I'm going to tell my shard server, and I got to tell it what collection I want to shard. So it's called our testdb.mycollection. And then I've got to tell it what my shard key is, right? So again, back to that whole hash map concept or a map concept. We got to tell it what its key is, so it's going to put based on those IDs, and then the one is telling it do it in sort order. So just like when you define indexes in a SQL world, do that. That's how we deal with shards in the Mongo world. All right, so now I'm going to get my shard distribution. That's going to tell me where's my data at in my system right now. So what this is telling me is basically everything's sitting on partition 1 right now. Not a big surprise. Again, I haven't pushed it over that chunk size. I can see I've got a single chunk, just like you can define page sizes in a SQL world. You can define chunk sizes there. Right now it's telling me the estimated size per chunk is about 4.5 meg. So the next thing I'm going to do is we're going to pump this up. This time I'll put 1 million records in there. And eventually we'll push it over that chunk size. All right, so we're at 137,000 records right now. And eventually we should just see it push over that. All right, so here's my partition 1 statistics. Here's my partition 2 statistics. I can see my shard on partition 1. I've got 58.34% of the data versus my shard 2, or my partition 2's got 41% of the data. So add those records that I've added to the database, it's picking which bucket do I put this record in, which bucket do I put the next one in, and it typically does it again by those chunks. So maybe there's 1,000 records in a chunk, maybe there's 10 records in a chunk. It all depends on how big your collection is and the elements in it, and how big your chunks are. And as it's adding that data, I can see that change. So now partition 1 is at 38%, partition 2 is at 61%. So behind the scenes, all that stuff that I just set up for us will decide which partition does this stuff go to, and try and keep those in balance as much as it possibly can. All right, so I'm at 305,000 records now. And it's still writing. It's on its way to 1 million, right? So what does everybody think is going to happen if I kill one of my servers? Is everything going to bomb out on us? Maybe. Maybe not. What happens if I kill 2 of those? Think it'll stop writing? Let's hope not. All right, so I'm going to emulate, again, back over here, right? I'm going to kill my first server. And I know, based on the way I set it up, that that's one of my primary stores. So let me get all my servers back up here. So I'm going to kill that server that's, serving up. This is my shard 2. Let me do a Control-C on it, because I'm going to start it back up eventually. But I just did a Control-C, so he died. Did a Control-C, Control-C. So that's emulating. I just lost one of my servers in production. So let me switch back over here and see if anything died over here. So it looks like I haven't seen any failures, right? It's still writing that data. I can come over here, I can look at my RS status. Oh, and that's one of, so this is, I was connected to 2700, so that's one of the guys that failed, which is fine, because this is, again, just a command line client that's connected to that guy. If I come over here and say, well, connect to the guy that's still up, and then show me an RS status, this is showing me that status, and you'll look, this guy's still in that replica set, but it's saying he's not reachable, he's unhealthy. This guy I know is the secondary, that's the one I just connected to, and now this 27002 took over as my primary store for that particular shards. All right, let's see. Is this one that I killed at? No, looks like I'm okay here. All right, so again, trying to collect my shard distribution. I'm at 17 and 82 now. The balancer is eventually going to balance that out, and there's also techniques that you can use to force the distribution that you want. So we're still there, so that's good. Let me see where our count is at on our collection. So we're at 640,000 records in our collection. Does that make sense? Try killing another server. I actually didn't try this, so maybe it's a bad idea, but we'll try it anyways. So now, which one do you guys want me to kill, the blue or the green? Blue? All right, let's kill blue. And actually, again, I want to do a Control-C on him because I'm going to start him back up when I'm done. All right, so if I switch back over here, right, what do you guys expect to see? Anybody? Right, I should see that primary is now dead, right? He died. Uh-oh, we might be in trouble here because I was expecting this guy to take over as the primary, but maybe it'll take over eventually. All right, so that guy died. So now I've got one server left on this shard, my partition 1. Let's see if my inserts died. No, they didn't die. Are they still going up? Hopefully they are. Ooh, what happened here? Am I on? Yeah, there it is. So no. So I killed my master before it had a chance to take over on the secondary. So obviously I've just disrupted my cluster. So bad demo, right? Let me see what else I can find. Yeah, so I can't see. Let's see what happens if I start up my other nodes, if they figure out what's going on. All right, so we'll start that guy back up. Let's see if it recovers. So that's a good sign. Yeah, so it's still writing, so that's a good sign. Now that it came back up, I still have my partition 1, my partition 2. Let's see what happens when I stand up my third nodes again. So we'll bring up my config server. Order shouldn't matter on which node I bring up first. Bring these guys back up. Right, so this would be emulating ops taking over and saying, oh crap, we got to restart those servers, or we got to bring new VMs into service, whatever it is that they need to do to recover. We're at 816,000 records, it looks like, and hopefully still going. Yep, still going. If I switch back over now and look at my replica set status, so that's one of the servers I bounced. So now I'm going to reconnect and see if things are back to healthy. Yep, so this 11 node took over as my primary, 10 is my secondary, 12 is my secondary. If I come back over and look at my other shard, right? So this is my partition 1 shard. We've got a secondary, a primary, and a secondary. So since I killed my first and my third server, right, my second one took over as the primary. We've got the 0, 1, and 2, right? And my 1 is now the primary on both of those. And when I stood up the cluster, I had a 0 was one of the primary and a 1 was one of the primary. So this kind of demonstrated, you know, we killed the primary, it failed over to the one node that we didn't kill. And I think we actually survived that server crash. It looks like it takes a bit for that primary to take back over, but we're in good shape. We've got all our records by the looks of it. My insert didn't fail. In theory, right, I could have sat there and had reads going on in the system at the same time. If we'd have put those into some type of a loop. So we're now over 1 million records in the system. It's still counting until we get to that 1,100,000, since that initial insert we did was 100,000. Makes sense? Any questions?
What if repository server goes down?
Say that again.
What if the left-hand side server goes down? What's it for that?
Yeah, so here,
Repository or what?
my routers, you're asking?
also.
Yep, so if I kill a router, and this is where the client side, it's really difficult to describe or to demonstrate, but all the clients, so that Mongo view is connecting to this router, so it's 27017, and this is my 27018. And there's no data there. All it's doing is servicing requests. It knows where the data is in terms of the shards and in terms of the machines. So if you look, like right here, I'm sure you guys can't see this, but this guy's connected to 27017, which represents one of my routers. And then these two guys are my routers. And I know by default, this is my 27017, this is my 27018. If I kill this guy, I'm gonna kill my particular update there. Well, he's actually done now. So, but that's a good question. I wonder if I assume that request had been submitted to the server and it will live on, but that's a really good question. We could start that again. So I'm going to start it at 1,000, and I'm going to try and kill it before that 1,000 gets done, and I think it'll actually go through, right? So we're at 1 million, 1.1 million, and now we're going to add 1,000 more, and I'm going to kill this guy, right? So he's dead now. I killed that guy. Oh, did it go too fast? It probably went too fast. But over here, this guy's not going to work anymore because he's connected to 27017. So I've emulated my first router going down. So now I'm going to connect to my second router. That's great. I'm going to say my collection count. Ooh, we didn't get there, it doesn't look like. So killing that, and maybe we might have even lost some records. I'm guessing we lost some records. Remember when that primary failed, and it took a while to take over? I'm guessing that there's failures too. So if I went and looked at my logs, I'm guessing I would see failures. So what's the lesson there? Well, maybe I need a fourth server if I'm worried about 2 out of 3 servers dying at the same time before a primary can catch up. But that count should be the same. And I do want to try and see what happens if I kill my second guy. So I'm going to connect this guy back to that second router. And then let's see what happens if I submit like a 10,000 request and kill the other guy before the die, or before. Yeah, so he's trying to reconnect. So if I start this guy back up, so my router's back up, right? So when both my routers are down, obviously I can't access my system at all. Does anybody remember what my count was before? No, I bet you I'm on the wrong DB. Yeah, so I'm on the wrong DB there, which that didn't work. But hopefully you guys get the gist of it, right? So what would be the lesson learned here, right? I can still lose data in the system. I can still have errors, right? So from an ops perspective, I got to be thinking about that. What's the chance of 2 servers going down? If that's too high for me, then maybe I need more shards or more replica sets, right? So if I had a 4th replica set, then if 2 fail, then I'm still okay. But if 2 out of 3 fail, in this case, I would have been in trouble. I would have lost. Some of my connections would have failed, etc. So even though we're setting all this stuff up, right, you still have to deal with, you know, the risks associated with and the costs associated, right? What's the cost of storing the data a 4th time and having a 4th server in my node versus the risk of actually losing that data or having downtimes with my clients. So you still got to be thinking about those types of things. Makes sense? Anybody got questions? Got a couple more slides, and then I think we'll wrap up.
So, router does the management of maintaining the replica and keeping access to which data is there on which replica.
Yeah. So when you send a request and say I want this data, the router works with the config server is what it boils down to, and then figures out, you know, which shard is my data on. And back to the whole primary versus secondary, and there's some config options there where you can say, writes always happen on the primary, but you can configure the system to say that my reads either only happen from primary or they happen from both primary and secondary.
Is there a possibility of data getting corrupted if the router goes down, or is where we have the information on how the shards are distributed on which system, and the router somehow goes down, so we lose information?
With from a request perspective, right, there's some guarantees around that. As far as think of it in terms of like a transaction in the database world, right? There are some guarantees around requests, just like you have a guarantee around like a store, for example, right? So there's an all or nothing concept in the SQL world. That's the the guarantees of the A in ACID, so atomic. Same thing at the request level, but not necessarily at the the concept of a transaction is much looser. Let's put it that way in a Mongo world. But again, those are some of the trade-offs that you're dealing with, right? So the notion around eventual consistency that we talked about, right? There's a chance that you're going to be reading data that's stale. But again, there's like in the Mongo world, that's a setting. So I can say I'm willing to read data from my secondary nodes because I'm willing to deal with some of those eventual consistency issues. But you're talking about milliseconds, if not microseconds in most cases. In most apps, that might be acceptable, but certainly, that's the things you want to be looking at, right? What kind of guarantees do I need to have around my data and the consistency of that data? Does that make sense?
Yeah, actually, I was talking from the point like this shard 1 and shard 2 are on different machines, so there must be some place this information has to be maintained, and likewise they have to be accessed. So, is there the primary server maintain this, or the router maintain this, and if they fail, so they might be a single fix, failure point. So, how the Mongo DB will manage that failure?
Yeah. So again, the idea is there's no single point of failure, right? So I've got config servers that all have the same information that's telling me where my shards are, where my primary, where my secondary. These guys are essentially constantly asking for that data and caching that data. The one thing that I didn't demonstrate that we have done, and I can show you guys, but we're probably light on time if people want to stick around, but the way you set up your system now. So back to what Paul was showing and his Mongo repository and the connections that we use to Mongo. The way you do it is you send a comma separate, or you configure your system with a comma separated list, and say these are my routers in the system. And so you would send into that connection router 1 and router 2, and then if one of these routers fails, the driver, so just like you have a JDBC driver, you have a Mongo driver, is smart enough to know that if this guy goes down, I'm going to start routing requests here. And so, and similarly, you've got that pretty much throughout the system with this notion of primaries and secondaries, and the notion of trying not to lose data. But obviously, if I lose both of these routers, I can't make any more requests to the system. I'm dead in the water until some admin or an automatic reboot brings those back online. So again, there's trade-offs with how much redundancy you want versus the risk associated with being down for how many ever seconds or minutes or hours it takes for your staff to figure out that you've got a problem. That makes sense? Okay.
You were demonstrating you showed the statistics. So it was like 67% of data
Yep.
by server 2 and 40% the remaining is on server 1.
Yep.
So now what it has done is it has partitioned that data and put it into different buckets.
Yep.
Now, like this guy has the 60% of data. So once this guy goes down, so that 60% of data was here goes down. So this guy is the primary, which this turns out to be the primary now. And then it has the only the 40% data. So how the replication is happening and that.
Right. So conceptually this is kind of hard, and but remember, so this is a strike through my data. This is my map, and these are my keys, right? So let's say it's an even and odd in this case, right? So I know all my odd stuff's going to end up here, all my even stuff's going to end up here. Again, you got to remember these are duplicate copies, right? So did I say these were my evens? Whatever I said, right? I've got a copy of all those records here, here, and here. And similarly, copy here, here, and here. And the scenario you're describing, right, is I lost all of those, and then you're screwed. You're definitely screwed there, and that's why, again, you have replicas. You've got them on different machines. Think if you're familiar with RAID, all that kind of stuff, right? It's the same kind of principles apply with how you want to distribute stuff, and you want to account for, again, server failure. Obviously, if all three of these fail, basically my entire server system has failed, so you're dead in the water. But the scenario that I was showing you guys, right, is I'm losing these guys, right? We lost these two, but I still have copies of those two. And in this scenario, right, I had that period of time where I lost my primary server, so I actually failed until it took over as a primary. And that's certainly a scenario that you can have, but how rare is it to lose two servers? If you lose 2 out of 3 servers, you probably lost something bigger, like had some kind of network outage or, a complete data center failure, which that's larger than this. And then you got to start worrying about, well, do we need 2 data centers so we can deal with that type of redundancy? And those are all things that, whatever you want to call it, the stakeholders, the senior people on a particular team need to be thinking about. And from a business perspective, what cost are you willing to pay to guarantee the health of the system versus, oh yeah, we don't need a second data center. We can live with being down for a day or two. Our clients are going to be mad, but maybe it's acceptable, and we don't want to pay the cost of standing up an entire second data center infrastructure. All right, so this one we hit on a little bit. Again, acid versus base. So acid, that's the thing where we're used to having guarantees around from a SQL world. A new thing is a term called base. And base stands for basically available soft state with eventual consistency. And we've harped on that eventual consistency quite a bit, right? So I know my primary is always going to have the real record, and it could take a few seconds for the replication to occur to my secondary stores. and that's the trade-offs that you're paying to be able to scale the system. And again, we talked about this at the beginning a little bit, right? So just like there's a pH scale in chemistry, and you talk about acids versus base, where they live on that scale, this goes back to that initial cap theorem triangle that I was showing you. And, you know, the acid piece is pretty much guaranteed, right? SQL databases have been around forever. But if you look at the NoSQL space and, you know, key value or column stores versus document stores versus graph databases, and then individual vendors within those, you know, they can wind up somewhere on that scale. And then similarly, you can have configuration for each one of those vendors. A lot of times that will give you different characteristics in terms of what you're looking for as it relates to acid versus base. All right, I think that's it. So I think we did the tying it all together piece with, you know, how we stand up a cluster, how we set up our shards, how we set up our replica sets to get our HA. We show a little bit of failover. I think I'd have to dig deeper on that second one and why we got the right failures and whether or not it showed up in the logs. But yeah, that's basically what we wanted to show you. For the stuff that I covered, Paul obviously embedded his references in the Spring stuff. I've also got some references here that you guys can take a look at. And again, down here, there's a couple of funny things if you're interested that, you know, I talked a little bit about the first one. Anything you want to add before we wrap up, Paul? No. Thanks. Anybody got questions? All right. Well, oh, go ahead.
Does Mongo DB have a out-of-box tool to monitor the replication, like event-based kind of model? Like if one of my server fails, it notifies whoever is monitoring.
I think we haven't looked heavily. I know Matt's installed some free tools, and I think there's some very expensive ones too that'll give you much more advanced. I can't remember what he said, but if I remember correctly, like in the 20Ks and up, like per year, again, depending on how big your cluster is and stuff like that. So, you know, that's where people out there, it's open source, it's free. Is it open source? I forget. It's free. I don't think Mongo is open source though. But anyways, that's how they make their money, right? So they make their money on consulting services and you know, on monitoring and management tools, that kind of thing. Very, very typical, you know, open source type model. I haven't even looked that closely at the free tools that Matt's installed, but yeah, there's stuff out there. I just don't know what it will.
Let's say that shard key, you have to change it out of rows.
Yep.
Already my data is distributed. So steps needs to be that I need to back up the data and like that.
Yeah, so there's something sitting out there like a background process essentially that's constantly evaluating, you know, what's the balance of my shard distribution, looking at things like, have new servers been added? Have I lost new servers? Have new shards been added? Has an admin taken away a shard? Have they changed the shard key? I did a very basic shard key. That's a thing from a design perspective, right? You want to look at access patterns to the data. And, you know, you probably want the stuff, like our example of that for us would be our property ID, right? We know that that's a hotspot where we're looking for the same data for the same property, you know, together, or maybe groups of properties. You know, that's what you want to look at in terms of your definition of your shard key. And using just what I did, the basic ID is probably not the best, something you want to look at, but, you know, just trying to show you guys the basics of how this works. All right, anybody else?
Could we actually change the shard key?
I'm pretty sure we could. Obviously, I don't have an options there, right? I've got the ID or I've got my value of X. But if I remember correctly, you can change the shard key.
I think so. We can change it because that is what it is. That while taking a shard key, as just deciding on the shard key, you have to consider many points.
Yep.
But then only decide the shard key. Because after that, if we are going to change it, it's not possible because the data is already on the server. And then we cannot migrate the server data from one server to another.
Yeah, you might be right. I mean, I'm not sure. That's something I'd have to double check. I think there's ways you could do that, but maybe there's more manual steps that you'd have to take, like build up a new collection and then define its key and migrate the data.
It's not a, you cannot do design for shard here, otherwise you have to go to the manual process. It's a decision that we made after
So it sounds like you're both right, and I'm wrong. We'll see. I'd have to look, right? I don't know if you can or not, but I think you guys are both saying the same thing, right? Design it up front and you can't change it without a whole lot of manual migration steps. All right, well, I think we'll wrap it up here. We'll be around. Grab us if you have questions or want to talk about stuff. I'll have to dig into what you guys were just talking about and dig into that log stuff too. All right, well, thanks everybody for coming.
Thank you.